Hi, I'm Knut. I go by Not Knut on Twitter, KNut, pretty much everywhere else. I do a lot of work in the open data movement, the civic tech open data field, and this is where I got to know Wikidata, which is a project that I got really excited about. So that's why I'm here to talk about it. So what is Wikidata? We have this thing called Wikipedia, which is very cool because we've managed to come together as mankind to create this collection of all of our knowledge. We've kind of managed to come together to just write down everything that we know about the world. Here, for example, we have an article about Berlin where we get to know that Berlin is the largest capital, the largest city and capital of Germany. The problem with this is it is written for humans, which is cool because it was meant to do that. But coming from the open data world, I'm really interested in like all of this, in getting data that I can use machines, that I can make machines understand. So Wikidata is kind of Wikipedia in machine readable. It's also a project by Wikimedia, which are the people that run Wikipedia. And every article that exists in Wikipedia also exists in Wikidata. So if we go to Wikidata, we see that there's also an article or a page for Berlin. It has a number here that is exposed. So we see it's getting a little more technical already. And then we see, okay, this article, it has labels, it has descriptions in multiple languages, and then there's statements about it. If we scroll down a long way, because this is a famous topic, Berlin, we see that one of the things this article says, it is the capital of Germany. It also used to be the capital of Nazi Germany, of the Kingdom of Prussia, and lots of other states. So the idea of Wikidata is, let's have what we have in Wikipedia, but have it machine readable, so that we can then ask machines questions about our complex world. So I want to talk a bit about how data is structured in Wikidata. And it's actually quite easy. In Wikidata, everything is stored in what is called a knowledge graph. And in a knowledge graph, you always have triplets. You always have subject, predicate, object. So in our example, we have Berlin, which is a subject. It has a predicate, which is country. And then it has an object, which is Germany. That's what we just saw. The subject was the page that we were on. And then there were all of these statements, which were predicates with objects. The cool thing is, this is a graph, so every object, such as Germany, is also a subject. Germany also has a page, and if we go there, we see that it has a head of government, which is Angela Merkel. It's an instance of a sovereign state. It has a population. And again, all of these dark blue things are both objects in where we see them, but they're also subjects. So they also have pages themselves with information about them. Not only that, but we also can have multiple statements about the same property. So Germany, in the article, we see that the head of government is Angela Merkel, but we also see that it was Gerhard Schröder, and we can specifically say, and this statement was true until 2005. So this is something that we don't have in traditional databases. Usually in traditional databases, we have like a column where we can have one value. We can have the value for head of state. It'll have one value. Wikidata accepts that the world is more complex, and sometimes there's multiple statements that are true or have been true for a while. And it's possible to have all of this in Wikidata. But again, the structure basically is quite simple. You always have this subject, predicate, object. And all of this, just like in Wikipedia, is managed by humans. So we can go into any Wikidata article, click on edit, and add a new statement if we see that there's something missing in Wikidata. Okay, so people go in there to model the data. Now what we want to do is we want to query the data. And just to give you a heads up of what we can do with it, one of the examples that is very famous in the Wikidata world is you can ask questions like, give me a list of the 10 largest cities in the world that have a female mayor. And I think this is quite a cool example because this is something we can answer with Wikipedia as well. We can go to the list of the largest cities. We can click on every city. We can see what's the mayor. We can see what's their gender. It takes a lot of time. With Wikidata, since all of this is machine readable, we can do it automatically. But let's start with a bit simpler example. So the Wikidata Query service is at query.wikidata.org, and it lets you write queries against this database. This is the a very simple example where this is in a language called SPARQL. It kind of looks like SQL if you've ever seen that before, but it's a graph query language. So we say, select all cities where, okay, now it gets a bit complex, but again, it's kind of subject, predicate, object. This subject we saw already, this is Berlin. This is a predicate, and then we want whatever matches that, and we want to call that city. So the first thing, as I said, is Berlin, and P190, this property is what we use to denote sister cities. So that's cities that are also called twin cities, kind of like the friendly cities of the city. So we're saying, look at Berlin, check what it claims are its sister cities and call them city, and then give me all of them. You don't need to remember all of these numbers by heart. The query service has auto-completion. So what I did to type this is I just typed WDT and then started typing sister cit. And then I got autocomplete, which said, okay, you probably want P190. So I'll show you all of the numbers in the following examples, but you don't need to remember them. The query service helps you with this. Okay, so this is how we can select the cities. And then if we look down here at the results, we see this is our cities. This isn't very helpful yet, though, because they're just identifiers. We probably want names. So we can add this extra line, which is called the label service, and that will give us for every variable that we have, such as city, it'll add another variable, which is the variable name with label appended. So now we don't only get city, we also get city label, which is the label in English. And if we scroll down there, okay, we see there's 21 results. That's the identifiers of the cities, and this is their labels in English. Now, this is a very easy example, but we can go on and we can use this fact that this is a graph to also query things on the next level. So we can say, find me all sister cities of Berlin, and for every city, find me the coordinate location and call it coordinates. I'm also selecting that up there. If I scroll down here, I see, okay, now for all of them, we also have a point property, which is where is the city? And now something that the Wikidata Query Service offers is we can click on this eye on the top left, and we can say, well, display this to me as a map. And then very easily, we just wrote 4 lines of query, and now we have an interactive map where we can see, okay, where are the sister cities of Berlin? We can also extend this some more. So as you can see there, for all of the sister cities, I'm not only getting their coordinates, I'm also getting their countries. And now for all of the countries, I want those that have English as the official language or any subclass thereof. Because, spoiler, one of the cities is Los Angeles, which is in the United States of America, and the language that they speak there isn't English, it's American English. But American English is a subclass of English, so this also queries this. And now if we execute this, we get a much smaller result set where we only have 3 cities left. So this is things that you can do with this. There's also other render modes. You just saw the timeline. Here we have an example of how to query what we just saw as the map. There's also the timeline. So here I'm asking which country is Berlin in? And then for the statements, I'm looking at the start and the end time. This is the example that we saw earlier in the visualization. I scroll down and I get this nice interactive timeline of what countries did Germany belong to. Some more examples. This isn't following the Berlin example anymore. This is how did American presidents die as a bubble chart. We also have, and these are all examples from the Wikidata service. There's an examples button that you can just click and then explore those. This is the population of neighboring states of Germany. So again, interactive line chart. Okay, so that's some examples of what you can do. Just a quick outlook for what is coming in Wikidata world. One of the things that was just recently added is lexemes, so lexicographical data, data about language. So now we can't only have statements about the word, but also about language and the words that we use for it, which apparently is very exciting for some people. And what also is coming is more and more institutions are creating their own Wikibase. Wikibase is the software that powers Wikidata. And with that, we can now make queries that don't only query Wikidata, but also query other databases and then use this common set so we can make queries across databases, which gets really exciting. I encourage you to try it all out. All of this is at query.wikidata.org. And if you have any questions, don't hesitate to contact me. Thanks.